So number 4, it says in the diagram above, BCD is a circle with center A. Angle BCD is 2x plus 40 degrees. This angle BAD is 5x minus 35 degrees. Angle BED is 2y plus 10 degrees. And angle ADC is 40 degrees. So we are required to find the values of x and y, and also to find the size of the angle B here, which is angle ABC. Okay, so I have set this up initially. For us to be able to solve this question, we just have to apply the rules of circle geometry. Okay, one of the theorems in circle geometry tells us that the angle at the center is twice the angle at the circumference. So BAD is 2 times 2y plus 10, which is the statement made here. So if that is true, then we just have to understand that this implies that we have 5x minus 35 is equals to 2, open a parenthesis, 2y plus 10. 2y plus 10. Okay, so we can simplify this. This gives us 5x minus 35 equals to 2 times 2y gives us 4y. 2 times 10 is 20. Collecting like terms, this becomes 5x minus 4y equals to 35 plus 20. 35 plus 20. So this is the same thing as saying 5x minus 4y equals to 55, equation 1. So we formulated one of the equations that we need. Then secondly, we also recognize that the opposite angles of cyclic quadrilateral are supplementary. So what's the meaning of that? It simply means that they add up to 180 degrees. So angle BCD plus angle VED will give us 180 degrees. The reason for this is they are supplementary angles. They are supplementary angles. Good. This implies that 2x plus 40 plus 2y plus 10, everything should sum up to 180 degrees because they are supplementary angles. Okay, we collect like terms, so we're going to have 2x plus 2y plus 50, 40 plus 10 is equals to 180 degrees. So finally, we can obtain the second equation to be 2x plus 2y equals to 180 degrees minus 50 degrees, which will give us 130 degrees. Okay, so this is equation 2. So what remains now is for us to solve equations 1 and 2 simultaneously. So let's see how we approach that. Okay, so I would like to rewrite these two equations for clarity. So the first equation is 5x minus 4y, which gives us 55 degrees. This is equation 1. The second one is 2x plus 2y, which gives us 130 degrees. We call this equation 2. Okay, so we need to eliminate either of, so I want to use the elimination method. So I will say equation 2 times 2. Let's see what I get them. So that gives me, multiply everything there with 2x plus 2y is equals to 130. Okay, so this gives us 4x plus 4y. Okay, everything is, then this is 260. We call this equation 3. So for us to eliminate, we simply say, let's see what happens here. Okay, if we say equation 1 plus equation 3, y should be eliminated. So equation 1 plus equation 3. So this gives us 5x plus 4x will give us 9x, minus 4y plus 4y gives us 0. Okay, then we add 55 to 260, and that gives us 315. So we can find the value of x. Simply divide both sides by the coefficient of x, which is 9. So this gives us 315 divided by 9. So we obtain the value to be 35 degrees. Okay, we know that 9 into 31, the closest multiple there is 27. So that is 3 remainder 45. That gives us 35. Okay, now we know that x is 35 degrees. Let's find the value of y from any of the equations. Okay, using equation 2, so I'll write from equation 2. From equation 2, we see that 2x plus 2y is equals to 130 degrees. So this will become 235 plus 2y is equals to 130 degrees. So we have 70 plus 2y equals to 130 degrees. Okay, so basically 2y is 130 degrees minus 70 degrees, which gives us 60 degrees. Therefore, y is 60 degrees over 2, which is equals to 30 degrees. Okay, so we've been able to obtain the value of x. X is 35 degrees and y is 30 degrees. Okay, so with this, we've answered the A part of the question, which is to find the values of x and y. So the next thing for us to do is to obtain the value of this angle. Okay, but before we do that, we need to recognize that ABCD is a quadrilateral. The sum of angles in a quadrilateral is 360 degrees. However, we need to determine the values of angle A, angle BAD, and angle BCD, so we can easily apply our rule and get the answer. Angle, we take a look at angle BCD, which is 2x plus 40. Angle BCD, which is 2x plus 40, is basically the same thing as saying 2 into x is 35. So the value of that angle is 70 plus 40, which is 110 degrees. Okay. Then let's take a look at BAD, which is 5x minus 35. So angle BAD was to BD is 5x minus 35 in bracket degrees, which is 5 into 35 minus 35 degrees. So let's see what we have there. So that gives us 5 times 35 will give us 175. We subtract 35 from it. This gives us 140 degrees. Okay, so we know the sizes of those angles. However, we see that angle ADC is 40 degrees. Angle ADC is equals to 40 degrees. Is given in the question. So we are required to find the angle ABC. Angle ABC. So angle ABC will simply be equals to 360 degrees minus angle BCD, which is 110 degrees, plus angle BAD, which is 140 degrees, plus angle ADC, which is 40 degrees. Okay, so this will give us, so this gives us 360 degrees minus 290 degrees. So the value of angle ABC is 70 degrees. So we have answered these two questions. Okay, let's see how we're able to do this. So we started out from the beginning by saying the angle at the center at A is 2 times the angle at the circumference. That led us to equation 1. Then we now said, oh, this is a DC is a cyclic quadrilateral. So we know that the opposite angles of cyclic quadrilaterals are supplementary. We use that fact to formulate equation 2. Then we went straight to solve the resultant simultaneous equations, obtain the values of x and our values of y. Then use that to obtain the actual values of those angles. Okay, before we're able to use the fact that the sum of angles in quadrilateral ABCD must be 360 degrees, and we obtained the angle B to be 60 degrees. So this is not a difficult question. We just have to apply our knowledge of basic circuit geometry, and we will obtain our answer just like we did.